Department of Biotechnology, Government of India organized a genomics data conclave at Vigyan Bhavan, New Delhi on 9th January 2025 in which Genome India data were released after a special video address by Honorable Prime Minister Shri Narendra Modi. Dr. Suchita Nivane, advisor DBT, in her welcome address said,
Namaskar, and we all are gathered here to participate in the landmark event, Genomics Data Conclave. It is indeed an honor for me to extend warm welcome on behalf of the Department of Biotechnology to all present here in person and in online mode. Last year in February, Honorable Minister announced the completion of whole genome sequencing of 10,000 individuals, and it was committed that we will make the data available to our Indian research community very soon. Sir, today we stand this day to fulfill the commitment made. Today we have gathered here to celebrate the success of Genome India project. Genome India data will help our researchers to find Indian solutions for Indian problems by accelerating research and development in different fields of biosciences. However, it is equally important to establish comprehensive protocols for data sharing to ensure judicious use, integrity, security, and reproducibility of the data. Earlier, this department has issued Biotech Pride guidelines. Now, ambit of these guidelines, the framework for exchange of data protocols has been formulated to establish a robust mechanism for data sharing and access. With completion of all these processes, we are now ready to make Genome India data accessible to our research community in a fair manner, transparent and responsible way. On behalf of the department, I humbly express my profound gratitude and happiness to Mananiya Pradhan Mantri ji. He kindly consented to deliver a special video address on this occasion that will strengthen our commitment for advancement of science in the country.
Dr. Y. Narahari, CBR, Indian Institute of Science, Bengaluru.
The Department of Biotechnology gave us an extraordinary opportunity to serve the nation by handing over the Genome India project exactly 5 years back. That the Genome India project was conceptualized and it was initiated, and through the dedicated efforts of the entire Genome India team, I think we have been able to achieve a few outcomes which are going to be like a watershed in genomics in the country. I would like to fondly recall the proud moment of 27th February 2024 when the Minister of Science and Technology, Dr. Jitendra Singh Ji, announced the completion of the whole genome sequencing of 10,000 samples. Not only that, he also inspired us to much more than what we have done. In terms of outcomes of Genome India, over the last 5 years, we have been able to establish a biobank of 20,195 samples for future research. We have completed the whole genome sequencing of 10,000 plus samples. Most importantly, we are ready with the digital public goods, and we have archived the sequencing data at IBDC. And we would like to consider Genome India as providing a pathway to genomics-based healthcare. The insights from the analysis have been extremely promising, and we expect that these findings will provide the scientific leads for affordable India-specific diagnostics and precision medicine. I would like to take you through a few early insights that we have been able to obtain with the analysis of Genome India data. To start with, this picture shows the allele frequency spectrum for as many as 130 million variants, of which 53.15 million variants have at least 3 minor alleles. Using this, a reference haplotype panel which was created has been found to have a very high level of accuracy even at minor allele frequency bins. This is going to be tremendous for coming up with imputation panels for cost-effective diagnostics. Then in another early insight, we have found that of the 20,000 or so genes, 5,700 plus genes have at least one loss of function variant, and these variants are both in the form of single nucleotide variant and also insertions and deletions. And we have found that all of these are high protein sequence altering variants, which is a very significant finding. When we look at an admixture plot of the Genome India data, it reveals tremendous genetic diversity in the Indian population. One of the major findings of the Genome India project has been to unravel the diversity that is very characteristic of India. And so you can see the 9,000 1,700 vertical lines partitioned into various GI population groups. The colors of vertical lines indicate different ancestries. And if you look at a principal component analysis of the Genome India data, this actually reveals 5 ancestries. And you can again see the kind of, migration patterns, admixtures, which are characteristics of the Indian population. On the pharmacogenomics landscape, the insights that we have obtained, they're already yielding very valuable insights into how people are going to respond to intake of drugs and so on. The data analysis that has been conducted so far also has led to the development of a Genome India database platform with which researchers, clinicians, and policymakers will be able to do genetic analysis and also planning. So with all these early insights and with the promise that we have of obtaining even more insightful observations, I think we have to look at the next frontier for the Genome India project. In some sense, the Genome India project has placed us at the cusp of a genomics-based health revolution in India. It has provided a pathway for understanding India's genetic diversity and has created a solid foundation for future studies. And the next frontier has to provide a comprehensive coverage for all linguistic and ethnic groups, a variety of healthcare settings and diseases, provide coverage to all tribal, rural, and underrepresented populations, and a coverage for all states and union territories of India. I think longitudinal studies are also required for a detailed understanding. I think for a country like India with a population of 1.44 billion and more than 4,600 population groups, I think the best way forward would be a 1 million genome program, including very specific disease cohorts. I think that will be a crucial step forward. Of course, this will call for such a mega project will call for highly distributed and well orchestrated operations, new funding models, and wide-ranging interdisciplinary collaborations. So with this, for providing this extraordinary opportunity for all of us and also for the tremendous support that we have received, we would like to express our deep gratitude and grateful thanks to our Mananiya Pradhana Mantri Ji, the Honorable Prime Minister of India, Shri Narendra Modi Ji. So to conclude, I think many thanks from Team Genome India. Many of them are here. Many thanks from all of us for the marvelous opportunity that is provided to us to serve the nation. We hope that Genome India will inspire the next generation of genomic innovators and herald a genomics-based healthcare revolution for India.
Dr. Arvind Sahu, Executive Director, Regional Center of Biotechnology.
So the feed protocols are the framework for exchange of data protocols. These are based on the PRIDE guidelines, or the promotion of research and innovation through data exchange guidelines, which are made by the DBT. So from morning, we heard various sessions and we understood the importance of genomics data. And as you all know, because of ease of sequencing, we are generating more and more data worldwide. These data are primarily located in NCBI or EMBL or DDBJ. But if you see, India is not lagging behind, right? And this is because the NGS one can sequence. And if you look in terms of the number of databases in India, we are 4th in the world. So in terms of whenever we get the genomics data or any kind of omics data, it becomes a responsibility to share it properly, right? And therefore there should be some guidelines. So the National Data Sharing and Accessibility Policy was formed in 2012, which was released by the Government of India. And later on, the Department of Biotechnology made the PRIDE guidelines for sharing the biotechnology guidelines with everyone. And this was released by Mantriji in 2021. So these guidelines are in harmonization with the international agreement and national policies, for example, Bermuda Accord, or for that matter, even the Indian policies like National Data Sharing and Accessibility Policy or Personal Data Protection Bill. So now question is, whose responsibility it is to share the data, right? So responsibility lies with all the stakeholders, whether they are funders, whether they are producers, where is the source, that means the individuals from where the sample is getting collected, or the users or the custodians like IBDC or Indian Biology Data Center where the Genome India data is kept. So it lies with everyone. And the feed protocols are the one which allows, right, to do this. What it does basically, it allows the modalities and decision-making process. It's important that we have set guidelines to do this, and this conforming to the Biotech PRIDE guidelines of 2021. These guidelines or these protocols are binding on all the stakeholders. So that's a important to understand that these feed protocols are binding to everyone. But in case there is a misalignment of national and international policies, then the National Act, rules, regulations, policies or guidelines, these will supersede. So PRIDE guidelines divide the data into three levels: is the raw data, the processed data, and the metadata. And the data access levels are either open access or managed access or no access. So how these data will be shared? So there will be a DMG or data management group. They will review the access as per the biotech PRIDE guidelines, and the decisions of the DMG will be reviewed by the EAC or the expert advisory committee on a periodic basis. And if the data that is submitted to IBDC is a no access level, then the DMG and EAC will report this to International Interministerial National Steering Committee, and it will go to them and they will take the decision on that. So these feed protocols basically define the responsibility of all the groups, whether they are data producers or submitters or the custodians or the users or the data management group or the funders. I will not go through the details of this, but the feed protocols defines the responsibility of each and everything which is related to the data, submission or the user or the management. And there are flow charts that have been made for the easy access of these data, and these are made for the users as well as those which are submitting the data. But this is quite complex, so let me simplify this for you. So let's say this is a managed access data, then the user registration happens. It is followed by the login and of course data request. This is primarily first reviewed by the IBDC members, then it will be reviewed by IBDC head, and then this will be going to the data management group. They will make a decision on this, and then it will be shared with the user. So this is the sort of a flow process through which it will happen. Now, where is the data located? The GENOMEINDIA data is located in Indian Biological Data Center, which is managed by RCB, or Regional Center for Biotechnology. IBDC has a HPC, which is called BRAHM, and that is where the data is. But the data is also, there is a recovery site in NIC Bhubaneswar. And IBDC not only hosts only the genomics data, but now it has various portals. For example, in terms of genomics, it hosts the open access data and the control access data, but it has crop phenome data, which is very unique to India. There are not too many crop phenome data overall in the world, and this is something which is very unique in India. We of course have the structural data and the proteomics data and metabolics data as well. All these portals are open and the data is being submitted there as we speak. So as you can see that the data which is deposited is increasing, and from 23 to 24 there is a steep rise. Of course, that is also because of the GENOMEINDIA data partly, but also we are getting more and more data. IBDC also conducts training, for various users as well as those submitters. And I would like to point it out particularly here. If you see that the usage of this data, IBDC, and you can see on your right that across India people are actually submitting and as well as they are using data. So it's open, and if you have any issues, please contact us and we'll be more than happy to help you out.
Dr. Rajiv Bahal, Director General, ICMR and Secretary, DHR, said,
I am extremely delighted to be here to be part of this celebration of Indian science as a proud Indian, just like all of you. The importance of this work cannot be understated. Human genomics research is critical in improving health and healthcare. In particular, it was mentioned earlier, it is absolutely crucial for achieving the coveted goal of precision medicine, which we are moving towards. Genomics is making great strides in understanding complex conditions such as diabetes or heart disease, mental health disorders, or almost any condition from most common to the rarest of diseases. Therefore, GENOMEINDIA, which is a unique data set in that it focuses on the diversity of our country by taking participants from all over India and giving the genome information, genetics information on all of them. I think it will greatly help us in understanding the genetic variations in our population, but also this data will provide a great opportunity for our not only academic and research institutions, but also for our industry to develop interventions, diagnostics, therapeutics, or preventive interventions, thus integrating genomics into public health. So I would like to congratulate the Department of Biotechnology and all the scientists involved with this Genome India project for their wonderful accomplishment. We struggle and strive as scientists for years to have small moments of joy and celebration. So I join in really wishing them this wonderful on this success. They deserve a lot of congratulations, and I wish them success in using these data for improving the health and well-being of the citizens of our great country.
Dr. Rajesh S. Gokhale, Secretary of Department of Biotechnology, said that with genomic data available, we can counter genetic and hereditary diseases.
I think today's event marked the landmark release of the Genome India data that symbolizes Bharat's scientific renaissance. For a very long period of time, we've been talking about our own genomic data, actually. We've had in bits and pieces and fragments everywhere, and we've been trying to scratch the data from different places to make it happen. And this is a real milestone for our country. It's a testament to our nation's renewed dedication to ingenious scientific growth, collaborations, more of the top of, and the creativity that will emerge out of this. As you would all realize, that genomic data acquisition now is the heart of almost all research-driven activities across various sectors. It's not only health. And this really sets us the standards for how we should manage and maintain our genomic data. The 10,000 genome program is absolutely outstanding in that way, is that we are now going to be able to release this data for every researcher working in every part of the world, not just in India, to be able to have an access to it, as Dr. Sahu so elegantly actually talked about it. It truly reflects how complex challenges and problems can be solved by a collaborative networks, which is what Department of Biotechnology is actually more and more promoting, actually, to bring together consortiums, people, to make sure we're able to take this, forte to the next generation level of activities. That this sets the standards, but it also makes us feel more ambitious to have 1 million or 10 million genomes of variety of kinds that will make us really proud for this country of small resource. I think one of the good things is that about 20 prominent institutions, whether they were from IISc, from IIT, from CSIR, from DBT BRIC institutions, they all came together to work on this platform. And I think that's where the real fun part of the game is, actually. And now the data is firmly secured at Regional Center of Biotechnologies, IBDC, the Indian Biological Data Center, that provides a wonderful resource for all of us to access. And my request to all of you is that every data that you generate, which you submit at NCBI for all the other purposes, please submit it as IBDC as well, actually. I think the more data we will submit, the more resourceful it will become. The team is already developing various creative programs and softwares on top of it that will be enormously enriching. And the primary data being in our country would be a transformative for AI-driven work that is likely to make sure the future's generation work. Of course, as we start using this data, we have to also be assured of how we make use of this data and what kind of valuable protocols, and the framework of exchange of data protocol that you talked about actually sets now an access for what we call fair, transparent, and open access to the biological data, while ensuring the ethical standards of protecting participants' privacy and fostering trust in scientific research. And I think that's all very, very important in the given that we actually live in this very complex world. I must say the Department of Biotechnology remains committed to delivering several such important events as we move along. And as I call the acronym DBT as Delivering a Better Tomorrow, we are likely to support several new endeavors. For example, bioeconomy and biomanufacturing is going to be immensely benefited by this baseline leveraging data in a variety of ways. As my colleague from CMRDG said, the precision medicine cannot happen without this. And I think what all we're looking for future of medicine is going to be precision medicine, of how we specifically identify diseases, how we specifically cure them, and how we provide protocols that are better for the person's individual perspective. It also provides efficient production of biopharmaceuticals, variety of other activities that will happen around this, actually. Moreover, the insight derived from the data can stimulate biotech startups. It can provide creative value of bioproducts while reducing dependency on traditional manufacturing products. The boost global competitiveness, and we hope that this will create new jobs and new activities as well, because as people endeavor into doing data analysis and activities, it will be wonderful opportunity for obtaining sustainability. The journey underscores the nation's strategic transition from being a hub of generic manufacturing to a global leader in biomanufacturing, and policies like BioE3, which positions biotechnology as a key driver of economic, employment, and environment goals, are pivotal to this transformation. Let us continue to build this momentum we have created, and I once again commend this extraordinary scientific team efforts for their success and dedication. Together, we will achieve many more milestones and contribute to our shared goals for a brighter and more innovative future.
Professor Ajay Kumar Sood, Principal Scientific Advisor to the Government of India, spoke about the transformative potential of this data.
I'm absolutely delighted to join the galaxy of dignitaries on the dais as it's indeed a great moment. I think Narari said watershed moment indeed to have the release of this Genome India data, but also a wonderful example of collaboration across the institutes along with the government support. I think this unique blend of bringing all the partners together, which is happening more and more in the last few years, this is one more example of the strength of this collaboration, which can deliver much more results with our efforts. Now, needless to say to this audience that the journey of science and technology in revolutionizing healthcare is a tale of unprecedented progress. In the last almost 75 years, I vividly recall on a personal note reading the book The Double Helix by James Watson when we were growing up. It was a fascinating journey, even the stories in that, how the discovery was made, how there was a competition to discover this double helix structure. I still remember in my student days reading that and discussing among ourselves. And I also recall when I do BSc and MSc, reading that paper again, and there was a very beautiful note in the last paragraph, which I took so much note because these days it is so important. All of us, when we write our papers, we say it's the first time we have discovered it. It is this, that. But in that paper, which is so fundamental, it made a very nice line, and I would like to read for you. It says, "It has not escaped our notice that the specific pairing we have postulated immediately suggests a possible coping mechanism for the genetic material." I don't think it could have been more prophetic, but it was so humbly put, example for all of us when we go overboard in making a small science results into larger than size. So this is really humbling. And at this moment, I thought I'll recall my impressions of those days when I read that paper. So we all know that we have come a long way with the discovery of DNA, and genomic has greatly enhanced healthcare by introducing personalized medicine, as was mentioned before, and transforming the diagnosis of genetic disorders. And this has shifted healthcare from one size fits all model to a more individualized approach. This is already happening in various countries where they are having a genomic database like US, UK, Japan, and so proud that India has joined with this first set of 10,000 genome sequences, and already promised by Dr. Rajesh Gokhale, and we take it very seriously whatever is said on stage, that it will be 1 million soon. You can aspire now, which was not happening earlier, and I am extremely confident that this will happen by this collaborative effort of academia, government, and industry. We need to bring more and more industries into the fold, and then this 1 million does not look a very dreamy target. It can be done. And for a country like India, we all should remember we are almost 1/6 of the globe, 1/6 on Mother Earth, with diverse demographies. The genetic makeup of this, our citizens, is extremely crucial. And whatever was said in the introduction by Rajesh and other speakers, we all know how it is important for tailoring the public health policies. And for that, absolutely congratulations to the leadership of DBT. Congratulations to the leadership of the country, Dr. Jitendra Singh ji, for supporting this, and to our Honorable Prime Minister, who has led from the front in taking this technology approach to look at the societal problems in no uncertain ways, when he also introduced Anusandhan as the fourth dictum along with other three from the Red Fort. I don't think it could have been emphasized in a better way. And we are all soldiers in that army to fulfill the dreams of taking this Anusandhan to the societal goals. And this genome sequence, the baseline data which has come up in these studies, will really serve a very, very decisive role. And this will help, I don't want to belabor how it will look at the very important problems like cardiovascular and cancer cases which are rising. I mean, the numbers are frightening in cancer when I read in the literature. And I'm very sure cancer research will take a very different turn when we bring the whole genomics into it. And this is, I understand it's happening, but it should happen in our country in a way that we can be the leaders in the world. So this dedicated genomics repository, needless to re-emphasize, will boost our research and innovation and bring bring advancements in personalized medicine and enhancing national security by reducing reliance on the foreign data, which is what we have been using. And we know it is not the best thing because our demography is different, our genomic makeup is different, and so on. So here I just want to mention two more missions, two important missions which will have direct influence on this genomic sequence. And that is the National AI Mission, which was launched in March 2024 with $1.3 billion investment by Government of India, almost like 11,000 crores, and the National Quantum Mission, again launched in 2024. So why am I mentioning again quantum? Because the conventional way of doing is the AI is doing by the classical computers using bits. But when the data becomes enormous, I don't think it has escaped people's attention that quantum computing is the future to look at the genome sequence along with other problems like climate change, weather prediction, all that. But genome sequencing, understanding genome in quantum computing is a paradigm which I am sure will be a reality in coming years. So this marrying the other two missions of what was announced by government and this Genome India initiative can really transform this whole approach to this biotechnology. And AI, needless to say, is a game changer which all of us are absolutely convinced that the way to go. So I think I will only mention one more thing from the point of view of this genome thing. We have the digital twin concept already for many years now, and now we are also having a concept of digital genetic twin, which is what the digital doppelganger. And this is what I think we should be also thinking right away in the research domain. How by leveraging insights from genomic data set, we can create a digital genetic twin. And this, which is a virtual replica of individuals' biological makeup. And using advanced AI and machine learning algorithms, this digital twin will continuously update with new data, reflecting changes in the individual's health status over time. So this innovative approach, I am sure, will highly personalize medicine with treatments and so on. And I look forward to really get to know more about this digital genetic twin in coming months and years. I am quite a fan of this digital twin, AR, VR, and all the new technologies. And this digital genetic twin, I have not heard much in India, but I hope that with the DBT and ICMR support and our leadership support, we would be making leadership role in this upcoming technology in the next 5 years. So it all looks excellent. We are absolutely delighted, and the proposed framework which was presented by Dr. Arvind on this FEED protocols again is very good. It assures you that it is in good hand, and there are protocols which will be followed, and there are safety issues which have already been put in place, which is so very essential in the days of cyber security and all the threats from our adversaries and so on.
Framework for Exchange of Data Feed Protocols, IBDC Data Access Protocol, and call for proposals on Genome India data were also released. Dr. Jitendra Singh, Honorable Minister of Science and Technology, Independent Charge, remarked,
If you see in a total perspective, I think the last 1 decade has been a game changer for India's biotechnology in more ways than one. If you see statistically, because we've been taught to speak through figures and statistics to make evidence of what we are saying, we were just about 50 startups in 2014. Now we've gone up to almost 9,000. We were just about $10 billion economy, went up to in just 8 years, now somewhere close to 130, 40, and looking forward to be 300 billion in the next few years. In the biomanufacturing, we are ranked number 3 in the India Pacific and somewhere around 12, among the first 12 in the world. And I think we had an opportunity of proving our acumen through the language of vaccine. Now, COVID came as a pandemic, as an adversity, but every adversity is accompanied with a virtue. So it came as a virtue for biotechnology, though I don't wish that it happens again and again. But it gave us an opportunity to prove to the world that we could come out with the first ever DNA vaccine. And to my mind, why it makes the rest of the world startled is that the world, particularly the West, never took us seriously as far as this was concerned. We were never taken a nation, even at the society level, very serious, but even over the therapeutic healthcare. If you fell sick, you waited for 3-4 days before deciding to consult a clinician or a physician. You waited for some divine powers to come to your healing. So many extra clinical remedies also got jungled up. So country like that, nation like that, because I remember when many years ago, one of the health ministers who said in my village, if anybody died, they would rather arrange prayers and say कि डायन आ गई थी, अब किसी और को ना लग जाए. She used to tell about some remote village in Uttar Pradesh. So for a country where even the therapeutic healthcare was not a priority, leave aside at the researchers level, even at the government level, the society level, that country today is being acknowledged as a leader in preventive healthcare. So that is something remarkable. That is what has taken aback the world. And this is not a fluke. Now we have come with the papillovirus vaccine and then series of others already in the pipeline. And then in the context of the subject today, the gene therapy trial in hemophilia conducted in Christian Medical College, Vellore, has found mention, in fact, a whole article in New England Journal of Medicine. Its question is that you could be a nationalist, but it's not the question of being less nationalist by finding acknowledgement by a recognized body. So now New England Journal, why I'm saying so to this audience who are already part of the fraternity, is almost 200 years old. And it belongs to the times when entire science was controlled by the United Kingdom, which is a larger Commonwealth world. Americans took over somewhere in the middle of the 20th century. And New England Journal of Medicine and the British Medical Journal, Dr. Behelwood, were the two premier journals came out of London. And if that journal publishes our trial, a trial which was led by the team headed by Dr. Rajesh Gokhale, means that they have vetted it through all possible parameters, and then they own the responsibility of telling the world that, look here, this is an authentic trial happened. It's not the question of the foreign journalists, but I'm saying, so that has actually given us recognition, acknowledgement, and made the world serious about the kind of work that we are doing. And most of it, as Rajesh was rightly mentioning, has been possible because we have a political dispensation headed by Prime Minister Modi, who is very intelligent, very supportive. These Bio E3 presentations again and again, going back to convince everybody. I sometimes tell myself that if we didn't have Mr. Modi as the Prime Minister, we won't have been able to get this far. It happened because, there were so many other skeptics saying, why are you indulging in this? What's the hurry? What's going to happen? So in repeated representations, we could explain to him that, look, sir, this is going to be the next phase. The bioeconomy is going to take over in a big way. And we, with our sources, huge bioresources, capabilities of regenerative processes, replacing the manufacturing economy, we could at least be into it. So I think that kind of support, encouragement has given us confidence to move on. That political patronage, which perhaps was not forthcoming in the same measure before 2014. And that has happened. I don't know whether that's happened to you because that occurred to you because that has a political connotation. This policy was among the highlights of the first 100 days of Modi government 3.0. And the other highlight of the first 100 days of Modi government 3.0 was allocation of 1 lakh crore for National Research Foundation, Anusandhan. Now, if that is the kind of prioritization in the political government, I think that speaks for itself with enough evidence. One more, because I wish that we go out and tell the people about this. You remember we had this vote of accounts. Whenever a government is going for election, they don't come out with a budget. With the sacrosanct spirit of democracy, that the budget priorities are the prerogative of the incoming government. So I leave that in the true spirit of democracy to the next government after the election. In that vote of accounts, we got two mentions. One was 1,000 crore for space startups and the other was semiconductors. In fact, even I didn't expect that. I went around telling others. Usually, vote of account consists of free laptops and sewing machines. So government going in for election is talking of semiconductors and the startups and space sector. So that is the kind of conviction with this government headed by Prime Minister Modi has worked and given us a different kind of culture. That's what has made it possible. And of course, as Professor Sood was saying, this is one of the beautiful illustrations of the whole of government approach happening. We have the ICMR, we have the other institutions, and I was telling Rajesh that we could also rope in the Tata Memorial because, as we mentioned, that we don't get enough of data from the cancer institutes. So we have other one or two, the private ones are also doing, like for example, I believe one or two institutes have established this SOP of going in for genetic studies whenever there are more than one members of a family having malignancy. But they don't come out with data, or they don't bother to provide us with to add to our data bank, as Rajesh complaining. But I think Tata, we can motivate it because it's functioning under the aegis of the Department of Atomic Energy, and we can request the secretary, which also comes under the purview of the PSA's office. So we could also ask them to be a part of this effort. And a larger ecosystem, which is now developing. And as Professor Sood rightly said, the artificial intelligence and the quantum are going to actually facilitate this. Now, as far as these two releases this evening are concerned, genes, as I said, is a relatively undervisited, or for many an unvisited area. So that makes it little exclusive, little distinct. And I, for one, and many of me belong to the generation we have seen this transition happening. Like, when we started off in our third year, we had a very met meticulous class of prescription writing, which doesn't happen now. If you tell the students now, they laugh at us. So they would tell us how to write the prescription for preparing a cough mixture, for preparing a diarrhea mixture, because pharmacology was in a very, very primitive state. And then gradually the advent of antibiotics, we used to have a posting just to learn injection. That was in third year. I remember the first injection I gave, the person collapsed. But the nurses were so generous. She said, no, nothing happened. Just give him this. So this was considered to be a skill and an art to be trained for. This no longer exists now. We've gone that far. When we got into post-graduation, the first day, your MD guide would tell you to get a retinoscope or a fundoscope, because you were meant to see the fundus, because whether it's hypertension, it's diabetes, it's malignancy, everything would reflect on that. Now the ophthalmologists don't use this because they place the face before the screen, and what you get through artificial intelligence is much better than the subject. So this transition has happened, and therefore gene therapy and all these gene-related options are going to be an essential part of the armamentarium in our future diagnostic as well as management techniques. And therefore, we need to, that brings the necessity of, and this is what I think we need to have also programs among the students, also in the public, because, of course, on our conferences, we started having two sets of it, the public speeches as well as the academic speeches. We need to, because where we need Indian data. And I always been saying for years, Indian solutions for Indian problems, Indian remedies for Indian diseases. For 140 crore population, they have gathered, and there are more than 4,600 demographic groups, and sequencing 10,000 individuals from different communities, as many as 100 or 99 communities, is no small task. But of course, the more larger and more representative would be the data. Therefore, we are aiming at 1 million, which would also be an exercise to map out the disease vulnerability, the disease susceptibility, because India is such a varied society and a community, even genetically. Unlike many of the European countries, there's no homogeneity at all. And it's been now understood that even a particular gene may behave differently in different communities. Like, for example, the atherosclerosis is more common, a pathogenic component for coronary artery disease amongst us, among the Southeast Asians. Whereas in the Africans, it is more in the cerebrovascular, causing more of brain strokes. So the same predisposing factor producing different outcomes because of the genetic variations. Our Indian phenotype, even Indians having settled in Europe for 3 generations, continue to have a higher propensity of certain diseases like type 2 diabetes mellitus, and even the central obesity. Only, I think, 2 months back, we released the data, this India Dive. Central obesity is equal in males and females almost in India, almost 63-64%. And it's known to be an independent risk factor for all these metabolic disorders, independent and regardless of the overall obesity, which is the reason why the Westerners appear to be obese and fat, but their visceral fat is very little. Unlike us, we wear a long kurta, wear a long sari, it gets camouflaged. So I think now the answers are going to be discovered through these data, and at the same time, the concerns about confidentiality were raised even when we started this exercise, and I'm glad I must compliment Dr. Sahu and the team for this framework for data exchange. Now, the point is that you want to exchange and yet not want to exchange. And then the dilemma is how much to exchange, how much not to exchange. So to decide the optimum of it is a great challenge. But without it also you can't move on. And therefore, this is an equal, I think, as part of the ecosystem, and particularly for the interdisciplinary collaborations. And I'm sure this, the exercise accomplished today will be a step forward in our world arena competitiveness in drug development, in personalized treatment of disease, which is something I think going to happen. For the same disease, you may not be amenable to the similar kind of treatment. And that will be determined by the nature of your gene or by the behavior of your gene. And then, of course, the breakthrough in the different diseases, like we talked about hemophilia, and of course, the rising prevalence of malignancies and type 2 diabetes mellitus in this country. And last, we also mentioned how to create more of public awareness about it. That's very important, because stakeholders are not confined only to the scientific fraternity. Ultimately, you are targeting a common citizen, regardless of his scientific acumen, scientific qualification, scientific knowledge. And your ultimate, in fact, in our times when the clinical medicine got more of supremacy compared to textbooks, we were taught the patient is the best teacher. So ultimately, your target is the individual. So unless you make him a stakeholder and you bring in pressures, like as Secretary DBD was rightly mentioning, the constraint of procuring data or not being shared, when we start getting pressure for the social groups, look here, for the benefit bit of a, like it happened in COVID. There was pressure coming in from the other groups as well, from those who didn't have a direct stake in research. So we need to create awareness about the importance of what is being done. Otherwise, to a common people, it appears to be something very vague. They feel we are sitting in a dark room, in a dark lab, doing something just to get a month's salary. They don't realize that what is being done has a very, very close bearing on their future existence. And therefore, I think we will devise a method of that through the social media options and also by arranging some kind of a public outreach program. But overall, whether today we realize or not, I think today is a day which marks a frontal leap for India as far as our excellence in the global role that we are envisaging for ourselves, and also for a bioeconomy driven fourth industrial revolution, because we have the advantage of that. The bioeconomy driven India's contribution would be based on our biodiversity, our biofoundries, our genetic data, and therefore to that extent in the coming times it may not be realized that deeply today. It is this group of persons, people sitting in this room, who would to an extent get the credit of having contributed to the making of Viksit Bharat. It may not be realized today, but I'm sure in 2047, when they who celebrate 2047, they would also look back to the contribution made by this team. Well, this is the future for the world, and India has already taken a lead.
Special video address by Honorable Prime Minister Shri Narendra Modi.
आज भारत ने रिसर्च की दुनिया में बहुत ही ऐतिहासिक कदम उठाया है। 5 साल पहले जीनोम इंडिया प्रोजेक्ट को स्वीकृत किया गया था। इस बीच कोविड की चुनौतियों के बावजूद हमारे वैज्ञानिकों ने बहुत मेहनत से इस प्रोजेक्ट को पूरा किया। मुझे खुशी है कि देश के 20 से ज्यादा दिग्गज रिसर्च संस्थानों जैसे IISc, IITs, CSIR एंड BRIC ने इस रिसर्च में अहम भूमिका निभाई। इस प्रोजेक्ट का डेटा 10,000 भारतीयों का जीनोम सीक्वेंस अब इंडियन बायोलॉजिकल डेटा सेंटर में उपलब्ध है। मुझे विश्वास है बायोटेक्नोलॉजी रिसर्च के क्षेत्र में ये प्रोजेक्ट एक मील का पत्थर साबित होगा। मैं इस प्रोजेक्ट से जुड़े सभी साथियों को बहुत बहुत शुभकामनाएं देता। साथियों, जीनोम इंडिया प्रोजेक्ट भारत की बायोटेक्नोलॉजी रिवॉल्यूशन का एक महत्वपूर्ण पड़ाव है। मुझे बताया गया है कि इस प्रोजेक्ट की मदद से हम देश में एक डाइवर्स जेनेटिक रिसोर्स बनाने में सफल हुए। इस प्रोजेक्ट के तहत देश में अलग अलग आबादियों से जुड़े 10,000 लोगों की जीनोम सीक्वेंसिंग की गई। अब ये डेटा हमारे वैज्ञानिकों, रिसर्चर्स को उपलब्ध होने जा रहा है। इससे हमारे स्कॉलर्स को, हमारे साइंटिस्ट को भारत का जेनेटिक लैंडस्केप समझने में बहुत बड़ी मदद मिलेगी। इन जानकारियों से देश के नीति निर्धारण और योजनाओं के निर्माण का काम भी आसान होगा। साथियों, आप सभी यहाँ अपनी फील्ड के एक्सपर्ट्स हैं, बड़े वैज्ञानिक हैं। आप भी जानते हैं भारत की विशालता और भारत की विविधता सिर्फ खान पान, बोलचाल और भूगोल की ही तक सीमित नहीं है। भारत में रहने वाले लोगों के जो जीन्स हैं, उनमें भी काफी विविधता है। ऐसे में बीमारियों का नेचर भी स्वाभाविक रूप से विविधता से भरा हुआ है। इसलिए कौन से व्यक्ति को किस प्रकार की दवा फायदा देगी, ये जानना बहुत आवश्यक। इसके लिए देशवासियों की जेनेटिक आइडेंटिटी, उसका पता होना जरूरी है। अब जैसे हमारे आदिवासी समाज, सिकल सेल एनीमिया की बीमारी एक बहुत बड़ा संकट है। इससे निपटने के लिए हमने नेशनल मिशन चलाया है, लेकिन इसमें भी चुनौतियां कम नहीं है। संभव है कि सिकल सेल की जो समस्या किसी एक क्षेत्र में हमारे आदिवासी समाज में हो, वो दूसरे क्षेत्र के आदिवासी समाज में ना भी हो, वहाँ दूसरे प्रकार का हो। इन सारी बातों का पक्का पता हमें तब चलेगा जब एक कंप्लीट जेनेटिक स्टडी हमारे पास हो। भारतीय आबादी के अनूठे जीनोमिक पैटर्न्स को समझने में इससे मदद मिलेगी, और तभी हम किसी खास ग्रुप की विशेष परेशानी के लिए वैसे ही विशेष सॉल्यूशन या फिर प्रभावी दवाएं तैयार कर सकते। मैंने सिकल सेल का उदाहरण दिया है, लेकिन ये इतने तक सीमित नहीं है। ये तो मैंने एक उदाहरण के लिए बताया। भारत में आनुवंशिक रोगों यानी एक पीढ़ी से दूसरी पीढ़ी को ट्रांसफर होने वाली बीमारियों के बहुत बड़े हिस्से से आज भी हम अनजान है। जीनोम इंडिया प्रोजेक्ट भारत में ऐसी सभी बीमारियों के लिए प्रभावी इलाज के विकास में मदद करेगा। साथियों, 21वीं सदी में बायोटेक्नोलॉजी और बायोमास का कॉम्बिनेशन बायो इकोनॉमी के रूप में विकसित भारत की बुनियाद का अहम हिस्सा है। बायो इकोनॉमी का लक्ष्य होता है नेचुरल रिसोर्सेज का सही इस्तेमाल, बायो बेस्ड प्रोडक्ट्स और सर्विसेज का प्रमोशन और इस सेक्टर में रोजगार के नए मौके बनाना। बायो इकोनॉमी सस्टेनेबल डेवलपमेंट को गति देती है, इनोवेशन को अवसर देती है। मुझे खुशी है कि बीते 10 वर्षों में देश की बायो इकोनॉमी तेजी से आगे बढ़ी है। साल 2014 में जो बायो इकोनॉमी $10 बिलियन की थी, वो आज $150 बिलियन से ज्यादा की हो गई है। भारत अपनी बायो इकोनॉमी को नई बुलंदी देने में भी जुटा है। कुछ समय पहले ही भारत ने बायो E3 पॉलिसी की शुरुआत की है। इस पॉलिसी का विजन ये है कि भारत आईटी रिवॉल्यूशन की तरह ग्लोबल बायोटेक लैंडस्केप में भी एक लीडर बनकर उभरे। इसमें आप सभी वैज्ञानिकों की बड़ी भूमिका है और इसके लिए मैं आपको अपनी शुभकामनाएं देता हूं। साथियों, विश्व के एक बड़े फार्मा हब के रूप में भारत ने जो पहचान बनाई है, उसे आज देश नया आयाम दे रहा है। बीते दशक में भारत ने पब्लिक हेल्थ केयर को लेकर अनेक क्रांतिकारी कदम उठाए। करोड़ों भारतवासियों को मुफ्त इलाज की सुविधा हो, जन औषधि केंद्रों में 80% डिस्काउंट में दवाएं उपलब्ध कराना हो, आधुनिक मेडिकल इंफ्रास्ट्रक्चर का निर्माण हो, ये पिछले 10 साल की बहुत बड़ी उपलब्धियां हैं। कोरोना काल में भारत ने ये सिद्ध किया है कि हमारा फार्मा इकोसिस्टम कितना सामर्थ्यवान है। दवाओं की मैन्युफैक्चरिंग के लिए भारत में ही मजबूत सप्लाई और वैल्यू चेन बने, ये हमारा प्रयास है। जीनोम इंडिया प्रोजेक्ट अब इस दिशा में भारत के प्रयासों को नई गति देगा, नई ऊर्जा से भरेगा। साथियों, आज दुनिया ग्लोबल प्रॉब्लम्स के सॉल्यूशंस के लिए भारत की तरफ देख रही है। हमारे आने वाली पीढ़ी के लिए एक रिस्पॉन्सिबिलिटी भी है, एक अपॉर्चुनिटी भी है। इसलिए आज भारत में एक बहुत बड़े रिसर्च इकोसिस्टम का निर्माण किया जा रहा है। बीते 10 सालों में रिसर्च और इनोवेशन के लिए पढ़ाई के हर स्तर पर बहुत जोर दिया गया है। आज 10,000 से ज्यादा अटल टिंकरिंग लैब में हमारे स्टूडेंट्स हर रोज नए नए एक्सपेरिमेंट कर रहे हैं। नौजवानों के इनोवेटिव आइडियाज को आगे बढ़ाने के लिए पूरे देश में सैकड़ों अटल इंक्यूबेशन सेंटर बने हैं। पीएचडी के दौरान रिसर्च के लिए पीएम रिसर्च फेलोशिप स्कीम भी चलाई जा रही है। मल्टी डिसिप्लिनरी और इंटरनेशनल रिसर्च को बढ़ावा मिले, इसके लिए नेशनल रिसर्च फंड बनाया गया है। अनुसंधान नेशनल रिसर्च फाउंडेशन में, उससे देश में साइंस, इंजीनियरिंग, एनवायरमेंट, हेल्थ ऐसे हर सेक्टर में और नई प्रगति होने वाली है। सनराइज टेक्नोलॉजीज में रिसर्च और इन्वेस्टमेंट बढ़ाने के लिए सरकार ने 1 लाख करोड़ रुपए का कॉर्पस क्रिएट करने का भी निर्णय लिया है। इससे बायोटेक्नोलॉजी सेक्टर का भी विकास होगा और यंग साइंटिस्ट को बहुत मदद मिलेगी। साथियों, हाल ही में सरकार ने वन नेशन वन सब्सक्रिप्शन का एक और अहम फैसला लिया है। दुनिया के प्रतिष्ठित जर्नल्स तक भारत के स्टूडेंट्स की, रिसर्चर्स की पहुंच आसान हो, उन्हें खर्च न करना पड़े, हमारी सरकार ये सुनिश्चित करेगी। ये सारे प्रयास भारत को 21वीं सदी की दुनिया का नॉलेज हब, इनोवेशन हब बनाने में बहुत मदद करेंगे। साथियों, जिस तरह हमारे प्रो पीपल गवर्नेंस ने हमारे डिजिटल पब्लिक इंफ्रास्ट्रक्चर ने दुनिया को एक नया मॉडल दिया है। मुझे विश्वास है उसी तरह जीनोम इंडिया प्रोजेक्ट भी जेनेटिक रिसर्च के क्षेत्र में भारत की छवि को और सशक्त करेगा। एक बार फिर आप सभी को जीनोम इंडिया की सफलता के लिए मेरी ढेर सारी शुभकामनाएं।
It is my honor and privilege to stand before you to express the deepest gratitude on behalf of Department of Biotechnology as we conclude today the Genomics Data Conclave. At the outset, I would like to extend our heartfelt thanks to Honorable Prime Minister Shri Narendra Modi ji for graciously sparing valuable time to address this gathering through the video message, despite numerous other commitments. His efforts to connect with us today speaks volumes about his unwavering dedication, commitment to scientific temperament and technological innovation in charting new territories for country's progress. His leadership has driven by a deep sense of purpose, which continues to inspire us all, and we are fortunate to be guided by a leader who not only articulates a compelling vision but also embodies the principle of hard work, perseverance, and resilience. Working in tandem with Honorable Prime Minister in realizing the vision of Atmanirbhar Bharat, Honorable Minister of Science and Technology Shri Jitendra Singh ji has been guiding force for the department. We extend deepest gratitude for his unstinted support and not only motivating us but empowering us to believe in future which we can collectively build. Sir, the vision you have shared today is just not the roadmap for progress, it's a call for action that compels us, each of us, to contribute with renewed dedication and purpose. We're immensely thankful to Professor Ajay Kumar Sood, PSA to Government of India, for gracing this occasion with your presence and also for inspiring the address that undoubtedly enriched our perspectives. I would also extend my sincere thanks to Dr. Rajesh S. Gokhale, Secretary DBT and DG BRIC, for his invaluable mentorship, unwavering support and thought-provoking perspectives. Thank you, sir, for the personal example you set for all of us, instilling in us the confidence to work together as a team for achieving the goals set forth. I would also like to express my sincere thanks to Dr. Rajiv Bhal, Secretary, Department of Health Research and DG ICMR, for joining us in this Data Genomics Conclave and giving insightful viewpoint on leveraging the genomics data for further health goals in the country. I wish to place on record my heartfelt thanks to Dr. Suchita Ninave for steering the Genome India project in seamless manner and coordination of this event and maximizing the outcomes of the program through her untiring efforts, unflinching support for all stakeholders. I would also like to express sincere thanks to all the distinguished dignitaries, panelists, speakers who have taken time to join us today. Besides contributing significantly to the success of this event, they have also presented that this research fraternity presents the new avenues and endless prospects for utilizing the data in solving critical problems. Our gratitude extends to the participants of the Genome India team who tirelessly worked out for the last 5 years for accomplishment of this project. I also wish to thank the members of Data Management Group, Expert Advisory Committee and National Steering Interministerial Committee for drafting and shaping of feed protocols. I would also like to acknowledge the tireless efforts of organizing committee and all the individuals behind the scenes. Without your dedication and hard work, this event would have not been possible. Just to mention, this has been hosted by RCB and IBDC teams, so this event would have not been possible. We truly appreciate your commitment to ensuring the smooth execution of this gathering. In the last, I would like to thank the senior officials of ministry, members of press, and all other dignitaries who are present online for joining us on this Genomics Data Conclave.
In this Genomics Data Conclave, many panel discussions such as understanding the importance of genomic research to the society worldwide, global ethics of data sharing, unlocking the potential of Genome India data for public health, etc. were also held, in which experts, scientists, and senior officials expressed their views. Narrated by Priyanka Kumari, scripted and produced by Dilip Jha. This radio report came to you from Indraprasth channel of Akashvani, Delhi.